Scientists have uncovered a full menu of atoms and molecules in an exoplanet's cloud using JWST, and some seem to interact. This recent discovery demonstrates that astronomers can peep into the atmospheres of unusual exoplanets and determine what's happening or being created chemically, and if these worlds may still have circumstances suitable to sustain life. Want to learn more about this mysterious discovery? Stay tuned till the end of the video. Astronomers targeted the exoplanet WSP-39b with the Space Observatory, which successfully reached its outpost 1 million miles from Earth this year. It's a hot, giant gas nearly 700 light-years away and orbiting a star. Previously, scientists on board Webb utilized special tools to identify the gas carbon dioxide in this harsh environment. The light from a star may frequently spark chemical processes on a planet, a process known as photochemistry. This is what's going on WSP-39b. WSP-39b is a hot, Jupiter-like exoplanet. The gas giant has 1/3 the mass of Jupiter, but is more similar to Saturn in composition. It circles its host star in 4 days and is 8 times closer to it than Mercury is the Sun, making it very hot at around 900 degrees Celsius. This closeness and the resulting light render the planet hostile to life as we know it. However, it also made it the ideal target for the JWST to examine early in its operational life, allowing it to test its exoplanet capabilities, according to Creedberg. Many exoplanets are too near their parent stars to be distinguished by even this powerful telescope. However, we may use the technique of seeing the planet when it passes in front of its star during transit. The planet blocks a tiny portion of the starlight, while an even smaller portion of the starlight is filtered by the planet's outer layers of the atmosphere. Some of the light is absorbed by gases in the atmosphere, leaving fingerprints on the starlight in the form of a drop in brightness at specific colors or wavelengths. Because it is an infrared telescope, JWST is ideal for studying exoplanet atmospheres. Most gases in the atmosphere, such as water vapor and carbon dioxide, absorb infrared light rather than visible light. In July, the telescope examined the planet for more than 40 hours. The initial findings revealed the presence of carbon dioxide in the planet's atmosphere. The gas was discovered for the first time on an exoplanet. Thanks to JWST, the scientists discovered that the majority of this massive planet's atmosphere had to be a combination of hydrogen and helium, the lightest and most common gases in the universe. Previously, the Hubble Space Telescope found water vapor, salt, and potassium there. Scientists have now validated the detection and calculated the amount of water vapor. According to the study, other gases include carbon dioxide, carbon monoxide, and shockingly, sulfur dioxide. Knowing how much of each of these gases is present in the atmosphere allows us to determine the relative amounts of the components that make up the gases: hydrogen, oxygen, carbon, and sulfur. Planets originate in a disk of dust and gas surrounding a young star, and varying amounts of these elements are expected to be accessible to a baby planet at different distances from the star. WSP-39b appears to have a low carbon-to-oxygen ratio, indicating that it transformed at a greater distance from the star, where it could have readily absorbed water ice from the disk, as opposed to its present very close orbit. If this planet has migrated, it might help us formulate ideas about planet formation and support the hypotheses that the huge planets in our solar system also did some shifting and shaking. For WSP-39b, the amount of sulfur discovered in relation to oxygen is relatively high. We'd anticipate sulfur to be more concentrated in fragments of rock and rubble in a young planetary system than as an atmospheric gas. As a result, WSP-39b may have had an unusually high number of impacts with sulfur-containing rock fragments. Some of the sulfur would escape as gas. Also, depending on how hot it is, various compounds react with one another differently in a planet's atmosphere. The overall quantities of each gas stay steady, while the reactions balance each other. For a variety of beginning points, the scientists researching WASP-39b projected which gases would be present in the atmospheres of the exoplanets. However, none of them produced sulfur dioxide, instead anticipating any sulfur to be locked up in another gas, hydrogen sulfide. A technique known as photochemistry was the missing piece of the chemical jigsaw puzzle. This is when the energy from photons, packets of light, emitted by the star drives the speeds of specific chemical processes rather than the temperature of the atmosphere. Researchers didn't anticipate the photochemistry to be as essential as it has turned out to be because WASP-39b is so hot and reactions normally accelerate faster at higher temperatures. Photochemistry is even more vital in colder, potentially livable worlds. A photochemical process creates the ozone layer on Earth. According to the data, light splits water vapor in the atmosphere into oxygen and hydrogen. These components would then react with the gas hydrogen sulfide, removing hydrogen and replacing it with oxygen to generate sulfur dioxide. The findings also revealed a low carbon-to-oxygen ratio on the planet. This implies that WASP-39b absorbed a significant amount of water as ice, most likely when it was in a different location, and that it developed considerably further out in its solar system, maybe similar to where Jupiter is, orbiting our Sun. It is unknown whether this is a leisurely process that takes tens of millions of years, or is caused by a gravitational shove from another planet or star. Knowing the composition of WASP-39b might help astronomers in determining which scenario happened. Because of the strong gravitational force between them, the planet is tidally locked to its star, with the same face always pointed towards it, and the measurements suggest that it lacks insufficient cloud cover, something astronomers have never seen before on an exoplanet. The Earth is only about 60% covered by clouds at the boundary of night and day, maybe because clouds evaporate as they approach the hotter side and condense as they reach the colder side. So, what's next for JWST? During its first year of operation, JWST will observe the rocky planets of the TRAPPIST-1 system. Some of these observations have previously been taken, and the temperatures on all of these planets are more comparable to Earth's. Some may even be the correct temperature to support liquid water on the surface and maybe life. Understanding how photochemistry affects atmospheric composition will be crucial for interpreting the TRAPPIST-1 system data from the Webb telescope. This is especially relevant since a visible chemical imbalance in an environment may indicate the presence of life. These spectra are just exquisite in their detail and reveal an additional way that the star affects the planet's atmospheric composition through photochemistry, says Victoria Meadows, an astronomer at the University of Washington in Seattle. Photochemistry, because it is such an important process here on Earth, is probably an important process on other potentially habitable planets, says Jacob Bean, an astronomer at the University of Chicago in Illinois, and the observation team's co-leader. Until now, we've only been able to test our understanding of our solar system's photochemistry, but planets around other stars give us access to completely different physical conditions. In its first year of science, which began last July, the JWST has seen around 70 exoplanets. WASP-39b serves as a benchmark in this research. Planets that the team plans to explore in the coming months include those in the TRAPPIST-1 system, which consists of a tiny red dwarf star orbited by 7 Earth-sized worlds, some of which might be shown to be possibly habitable via transmission spectroscopy. In December, the telescope will see WASP-43b complete a whole orbit around its star, which will span 1 Earth day. This will provide previously unknown facts about the planet's temperature and chemistry. That brings us to the end of today's video. Please leave a like and a comment if you like the video. If you're new to our channel, subscribe and click the notification bell to get alerted when we post new material.